Hello, everybody. Welcome to this session of GeoAI Bytes. And as it's the 31st of October, it's Halloween, GeoAI Vampire Bytes. There'll be no more very cheesy puns after that, and I'm not in any sort of costume, so don't worry. That's the only one. Today's session is going to be about why pre-trained models fail. That was our title we're going with in social media posts, but actually it's why pre-trained models suck, and the importance of human in the loop. Now, we have very few slides today's session. What we're going to have is a little discussion between myself and our lead machine learning engineer, that's Roger Fong, who will join us in a second. Any questions, please do put them through into the various event pages, into the comments and the chat panels, and we'll get around to answering those at the end. So without further ado, I'd like to introduce Roger. Hello, Roger. How are you?
Hello. Hi, Dan. Yeah, I'm good. Yeah, I'm Roger. I'm the lead machine learning engineer here at Patera. I've been with the company for about 5 years now, and yeah, happy to be here and discuss with Dan about these pre-trained model things.
Great. Thank you, Roger. Well, actually, first off, I'd like to kick in, and again, kind of, if you watched the GeoAI Bytes from last week, you know that I'm a marketeer, so I have not that much knowledge and background in the whole machine learning world in terms of a technical perspective. So I'd like to ask you, Roger, can you explain a bit about what a pre-trained model is and why they've actually become very popular, especially very recently in the machine learning world?
Yeah, so good question. So basically, with any machine learning model, a model always requires some amount of training. So you have to give it basically some data for it to learn from. And the idea behind pre-trained models is that well, someone has already done all the heavy lifting for you in terms of training that model with some kind of data somewhere, and it's already been trained. It's all set and it's ready to go. So that's the idea of it. And you can imagine that this is kind of a popular concept, especially for companies, like companies trying to take advantage of AI who don't have much AI experience, because the implication there is that basically, since these models are already pre-trained and ready to go, all you have to do is click a button and then boom, magic, everything works, right? So pretty low commitment. Like all of a sudden you get automation basically for free, right? So it sounds like a very, very attractive idea on paper.
Yeah, sounds ideal. Why wouldn't anyone go for that? I mean, sounds great. But in reality, kind of in practice, why do you believe that they often fall short? I mean, we've used the title fail. We kind of say they suck a little bit.
Mhm.
And especially when we're talking about geospatial imagery, so satellite, drone, aerial imagery.
Yeah, so that really goes back to what I just said about somebody doing the heavy lifting work for you and having trained the model on some other data. What's that data, right? Like that's really important to know. If you can imagine like all the possible ways to see the world, especially with geospatial imagery, like all the different sensors from different satellites, all the different resolutions, every single possible location in the world you could probably take a picture of. It's like it's near infinite, right? I mean, it's not infinite, but it's a huge amount.
Hmm.
We're nowhere near capable of gathering all that information and training a model from it. Even when you talk about like Google's like massive models and things like ChatGPT and Segment Anything, they're still trained on a very small subset of what is actually possible in the real world. So when you try to adapt those models to a specific task that you are working on in your domain, I mean, if it's not trained on your data, then it's not going to work very well. Um, I guess I don't know, maybe it's best for me to provide some examples.
Yeah, I mean, it's an example where perhaps one didn't work quite as expected, let's say.
Yeah, I think the classic one is, for example, with everyone getting into geospatial and AI, they start with buildings. That's like the most classic one. And oftentimes people think, oh, pre-trained models on buildings. This model learns how to detect buildings, but that's not true. That's not actually what the model learned to detect.
Hmm.
That model learned to detect this specific type of building in this specific type of geographical location in the world, uh, with this specific type of sensor or at a certain resolution, right? That's the real name of that model. So when
Yep.
you say building detector, like, well, what's your resolution that you're trying to look at? What's your part of the world, right? Chances are it's not going to work very well. We've
Yeah,
seen
and
that
actually,
many,
I,
many
I, I
times.
talked about this in last week's session. If anyone
Hmm.
watched that one, if you haven't, please go watch it on demand. It's available now. So I talked about the example of there was a city, Bellingham in the US, where a detector was built for that particular building type. And then looking over to the Cameroon, I think it was a separate detector had to be built for the building types in the Cameroon.
Yep. Yeah, that's. Sorry, go ahead.
No, I was going to say, apart from buildings, what kind of other examples might there be where these pre-trained models fall short?
And in fact, I think we have some slides on a pretty good example of something that happened recently that's been buzzing on social media as well. So of course we all know about the Ukraine conflict. So Microsoft AI actually tried to help with the conflict by detecting damages from the war. And what they did was they took these models that were pre-trained on disasters that were disasters in North America and in Africa. But got those areas right. But in the end, they didn't work in Ukraine because, well, first of all, different part of the world, and second of all, the damages. There's a difference between damages from natural disasters and damages from war. And conceptually, you think, okay, well, damages to buildings are damages, right? So it should work. But in practice, the imagery itself looks quite different in the end. There's a lot of different things going on. I mean, the concept of damage itself is really quite an open, broad concept, right? So in the end, well, as the quote says here, the models failed miserably, and I mean, those Microsoft AI themselves who made the statements like, yeah, we should have made a custom data set or something to train specifically for Ukraine because clearly this approach of using this out of the box pre-trained model just didn't work at all.
Okay, and then in that respect, then so the custom models you just mentioned, how do they tailor to specific data sets? How do they to specific tasks? How do they address the limitations of those pre-trained models specifically?
Yeah, I mean, it's clearly a bit more work than the pre-trained, but it's also necessary work to gather the data, for Ukraine specifically, do the proper annotations there, and create a data set that's specific to your geographical location, your type of damage, the resolution of the sensor, etc. I mean, by doing this, you're actually, you're telling the model like, yeah, I want damages of this specific nature, right? And that's important because, I mean, a machine learning model itself is just a blank canvas. It can't, if you only, like, as humans, we know what damages are because in life, as we grow up, of course, we see all sorts of types of damages of different varieties. And then when we see one, I mean, we're all able to understand what damages from war because we've all seen what that looks like from various news and media, right?
Sure, so, sadly, yeah.
Yeah.
I had another example actually I wanted to get your observations on, and this was something where it's all about ensuring machine learning adaptability to changing context. So, what can you tell me about this?
This is actually a funny one because, well, not to say funny, but it's an interesting one because, yeah, I mean, clearly, the Russian military also realizes the weakness of pre-trained models in this case, right? Because they basically wanted to prevent like satellite imagery or automated models from being able to detect automatically how many planes they had, for example. And yeah, I mean, if your models are trained on white planes and hasn't seen any example of black planes or vice versa, it's not going to find them. So in fact, they or in this case, they painted silhouettes of aircrafts on runways to kind of give false information about how many planes were actually there. And this kind of thing is, I mean, it shows that there's quite a bit of already a bit of recognition of the fact that the pre-trained models are quite weak to sort of these fake images here, and that also highlights the necessity for machine learning models to be able to adapt to training contexts quickly.
Yeah, what was interesting with this example, actually, when I saw it, was they spent all this effort and time and obviously resources to paint these outlines of the aircraft on the runway, but they didn't go quite as far as painting the shadow. So you can tell from the human eye, obviously, which is the real ones and which are the fake ones by the absence of the shadow. But that is something that pre-trained models might kind of trip over and actually identify as an aircraft, right?
Yeah, again, then you could train the model to, if you had adaptive model where you had control over it, you could then add in more data, for example, saying to I don't know, like not detect the yeah, to ignore the ones that didn't have a shadow, right?
Right. Yeah.
And then I probably would have, with some tuning of the model, I guess, probably would have been able to solve that problem.
Okay. So let's move on to kind of the human in the loop approach. So how does that approach complement what we've discussed around custom models? How do we ensure that we get better outcomes overall for any sort of geospatial tasks that we have?
Yeah, that's a good point. Talking a lot about custom models, so you might think, oh, okay, yeah, so we should just hire like a consultant to like build us a custom model for our data, right? But there's also a little bit of a risk that you're taking as well, right? Because in the end, if you're hiring someone else to do it, then you're not in control of your own data itself. I mean, you're in the end, maybe there's a bit of more customizability because you're talking directly to someone about it, but it's customized in the way that you're interacting with this third party, but you're still not necessarily seeing what's actually going into the model. And so that's a bit the goal behind the Patera platform here, is to give you yourself, the client who's actually trying to solve the problem, control over your own data set and your own model. And so as you can see from this animation here, with the platform, you can actually go in and annotate the data, find the weaknesses of the model, like the planes without shadows, make those annotations yourself, and then teach the model yourself what it needs to learn. And that's a really powerful concept because, I mean, now, no AI model, even the pre-trained ones, are perfect, right? And that's another issue with pre-trained models, is that even if it happens to do a good job, you get lucky and get like I don't know, 90% or something, you're still like, okay, but where's that extra 10%? And like, how do I make it better? And with pre-trained models, you're stuck there. You can't do anything. That's the end of the game. But if you are in the loop with the model yourself, then first of all, you kind of already understand what the weaknesses of the model are because you've been the one building the data set, right? You're like, oh yeah, maybe I forgot to annotate so-and-so or here and here. And in fact, the platform actually has a data set recommendation tool to kind of offer you recommendations of where you might have missed some places to annotate. And so with that understanding, then you can actually iterate on your model and improve and squeeze out some extra performance, past that 90%, for example. So yeah, that's a really important concept, to be in control of your own model and your own data sets.
Okay, awesome. And drawing on some of the things you kind of mentioned in that response, and right at the start of this discussion, we talked about big models like ChatGPT, for example. You can't move on LinkedIn for posts about ChatGPT in the past year. But what about those huge pre-trained models that do learn from massive data sets?
Yeah.
There's so much hype. That means they work, right? They must be great.
Yeah, I think it's important to think about what the output of the model is, right? Like what's it's actually doing. Like ChatGPT it's easy to hype stuff around it, right? 'Cause it's something that generates some kind of text, and it's very like relatable to the population, right? But does that necessarily mean that that also applies to like specific segmentation of the specific building type you're looking at, looking for in this type of satellite imagery? I mean, not really, right? It's a completely different ballgame. And another thing about ChatGPT, well, okay, there's two comments I want to make here. First of all, it's about language, right? And language actually is less complex than imagery. I mean, if you think about it, language is already defined in certain sets of rules. I mean, because we as humans, like, we have a grammar and structure and everything, right? And so it's actually a bit easier to learn what proper grammar is versus imagery of the natural world is much more unstructured. I mean, maybe there's some natural order to things and how nature is structured, but it's a lot more chaotic than the human language. So that's one point already. And the second point, and this is kind of a funny one, you might think like ChatGPT is super smart, it can answer all your questions. So we were at the CVPR conference just last June, and actually a lot of the researchers there were saying, actually ChatGPT kind of sucks. And they gave a great example. If you just ask it something like any 3-digit number times any other 3-digit number, like, I don't know, 386 times 414. More than 50% of the time, it's gonna get it wrong.
Wow.
It's just like, and yeah, a basic calculator will do better, right? And it's a bit like, okay, well, why is it just not smart? Is it like, is it a hard problem for it? It just never really learned, right? Because there's some kind of, I mean, it learned on languages, sure, but like no one on the internet, it probably learned off a huge internet database. but no one on the internet is specifically asking like 386 times 414 or whatever I said. It didn't learn it, so it's just like, well, I'll just kind of do some random stuff from like other maybe like circumstantial multiplication questions that other people kind of asked over some like random forum and see if it works out. And yeah, I think the stat is like if it's a 4-digit 5 times 4-digit number, it gets it wrong like 99% of the time or something like this. So yeah, it's that.
I was going to say that's about my error rate. I think I'd probably get it wrong 99% of the time as well, given I can't remember how to do long multiplication anymore.
At least if you work out the little like steps and stuff and everything, right, you'll probably get it. But yeah, so I still would say that you're smarter than ChatGPT.
I'll take that. Great. So I mean, go on. You had a second point about ChatGPT as well, right?
Yeah, I actually want to talk about this is another buzz about this model called SAM, Segment Anything, from Facebook, which is there's a lot of buzz about. Yeah, you just feed it an image and it'll just like segment everything in your image perfectly. Yeah, that's a bit of an overstatement. So, I mean, we actually tried it on geospatial, maybe for like natural imagery that you take from like a camera or something, like at ground level. Maybe you might get some reasonable looking outputs. I mean, don't expect specifically what you want, but it might kind of roughly segment different parts of the image into like, person, sidewalk, that kind of thing. We tested this approach on just like basic geospatial imagery. It was a satellite imagery of just like some farmland and like some barns. And yeah, I got some of the barns, and what else it got was just like random patches of farmland, but like only some of it, but not all of it. And it missed some buildings, and it just seemed really random. It got some shadows here and there. So, I mean, it just didn't really work very well. But we still use it on our platform for something. We use it as a tool to actually, as a magic wand tool for annotations. Because what we did find is that if you give it user input, back to the humans in the loop thing, if you click on the thing that you want to segment specifically, not just like segment my whole image, it actually does a good job of finding like roughly the concept of like an individual object. And in that way, you can segment things that are a bit more complicated to annotate manually, like bodies of water, for example, that are a bit kind of crazy and curvy. So that's a really useful, that's a great use of the tool. But again, that's in the humans in the loop kind of application.
Yeah, and regular viewers, just to cut in, of GeoAI Bytes will know that from last week's session, I demoed that to actually, yeah, as you say, you can click on the paddle pitches, the paddle courts that I was trying to build a detector for, and it does a great job of actually outlining and saving you having to annotate something that might be a bit more complex. Okay, but one point I wanted to bring up as well is that when you're training your own model, people are often concerned, they often have worries about how much data they might need to annotate, to get a reliable, to get an accurate model. So how can custom models address this particular concern?
Yeah, there's actually a bit of a misconception there. This kind of perception of needing tons and tons of data is actually something from academia, where they are working with huge data sets that try to cover as much of the real world as possible. And I mean, in academia, right, you're trying to make a breakthrough that can like revolutionize the world, right? So it's natural that a lot of the data sets they have are also gigantic and expansive. In industry, oftentimes there's a client with a specific need. They want to detect a specific type of crop over their specific farm. You don't need a data set that covers like huge expanses of a country in order to make the detector work, right? You need data just for that farm and that type of crop. And when you get to that amount of data, when you get to that kind of scope, the amount of data that you actually need shrinks by like orders and orders of magnitude. I mean, we have seen cases of like it depends on the imagery, of course, but cases like, I don't know, detecting like bolts or clips on a railway. And railways are like a nice structured kind of setup, and the bolts, they kind of all look the same. You can pretty accurately detect all of them with like 10 to 20 annotations. It's like it's in double digits, right? So, and you think of how long it takes to annotate 10 or 20 bolts. I mean, it's not that long, right? Admittedly, some cases are maybe like hundreds of annotations, but even then, it's not in the levels of like hundreds of thousands, right? Or millions, which is the case for like I don't know, very famous data sets like ImageNet. So it's a lot less daunting than you might think. And once you get into it, it's actually quite of a cool process because you actually see the data set that you're building and iterate on it, as I said before, and you feel more in control of everything that you've built for that model.
Okay, gotcha. Okay, great, interesting. So we're coming to the end of the session. So before we wrap up and go to the Q&A, any last takeaways? Anything you'd like to impart to the audience on this topic?
Yeah, I guess I don't want to beat the point too much to death, but the point I usually try to make is that just maybe don't think of AI as sort of this magical black box do it all kind of tool, right? I mean, it is a tool, but it's not like you have to use that tool correctly, right? I like to use the analogy of like a hammer, right? If you're building a house, you can't just throw the hammer at a pile of wood and hope that it's gonna magically like erect itself, right? You gotta like take that hammer, find the right places to put the nails in, hammer in all the right spots, and once you do that, you have a house. It's great. So I mean, it is some work there, but without that hammer, you wouldn't have been able to build that house in the first place. So a lot of people like they hear this like, oh, actually, I do need to build my own data set. Pre-trained models don't work very well, and they get super discouraged about AI in general. But that's a bit missing the point, right? Like AI is super powerful. You just need to use it correctly. And maybe one day we will have a sci-fi level AI, but yeah, we have to take steps to get there, right?
Yep, exactly. Fantastic. Okay, well, Roger's going to hang around for a bit of a Q&A session now. So if you do have any questions that you want to ask Roger, please do so now. So whatever platform you're joining us from today, just add a comment within the chat interface or the event post itself, and we'll do our best to answer as many as we can. But just before we finish, thank you so much, Roger. That was really interesting. Look forward to seeing you on a future GeoAI Bytes. Thanks, everyone.
Thanks.